Van and Myra and myself were just going to take the opportunity to tell you a little bit about the Max Bogl Tarmac joint venture and the FFB Max Bogl system. We're going to tell you a little bit about the history of Max Bogl and their slab track system and the development thereof. So a little bit about track installation, which is important to the Tarmac Max Bogl solution because it is an integrated solution. It's a turnkey solution that we provide. A little bit about noise and vibration mitigation, some projects that Max Bogl have been involved in around the globe, and then we'll just close up with a little bit around about the service provision for the Max Bogl Tarmac joint venture in the UK. Werner.
Thank you, Steve. Good afternoon, ladies and gentlemen. History and development of Slab Track. In the 1960s, the German railways thought about riding a little bit faster, but having better comfort and maybe less maintenance. So this was the start of development of Slab Track. In 1972, the first section has been built quite close to radar station, and it was a cast-in-place system based on sleepers filled with concrete. The development was running by some companies, and 5 years later, in 1977, demonstration track was built quite close to Munich in the line between Karlsfeld and Dachau. Different systems, some with sleepers and in situ concrete, and also systems with precast elements have been performed. Here we can see a very big picture. It was the section out of this demonstration track built with precast elements in the length of 430 meters. This is a picture after 15 years of use. Quite a lot of other systems during this time have been renewed. This system is still running today, every day used by trains with a load of about 160,000 tons. And we call it the mother of the FFB system, Feste Fahrbahn Bogl, because with this good experience of this system, the German railways asked Max Bogl, because they have quite a knowledge in precast technology, to take up this solution and the brilliant experience out of this test track to update this system, and the FFB system itself was born. Integrated rail seats, longitudinal coupling, and maintenance free, the track work itself, since now more than or about 40 years. A very good performance. And now I want to tell you a little bit more in detail about the FFB system. The description of the slab track system Bogl. The FFB system consists of precast concrete elements produced in a precast plant, length of about 6.5 meters and a width of 2.55 meters with a dead load of about 9 tons. As a unique feature, we have the longitudinal coupling, providing a higher resistance against lateral movement, what's very important for the long durability of the system. And we have the pre-stressing in transverse direction to increase longevity and durability. Each slab has 10 pairs of oversized rail seats. Oversized because the following process, what is a machined process, performed by a grinding machine, will work in this oversized area, what we can see here. The unique feature is not to change the inserts in the mold to achieve a curve. No, we install the curve by a grinding operation. The rail seat geometry after grinding has a shape of exactly the track alignment. The grinding process can be performed by fully or half profiled shape rolls. The amount of material to be grinded off vary from a range of 1 millimeter to some millimeters. For quality control, after grinding, each slab and each rail seat will be measured by a laser scanner and checked if the grinding rate is in the expected range. For quality control, all the data measured by the laser scanner will be stored. Because now we have a unique slab with the geometry of a special part of the track, this slab gets an ID number, and this number will be performed, you can see it here, by a small robot. But how to bring a some kilometer long railway line to a segmented track? Basis is the track geometry given by the railways. This alignment will be used in all following processes as basis. In the planning process, the track is broken down into pieces with the length of the slabs, and so for each place of the track a slab will be designed. An individual data set is generated in the FFB software for each slab. The data will be used for the CNC grinding machine and also later for the slab laying and the adjustment on site. The data can be stored also in the BIM model of the railways. So the software of the FFB system can work together or can be part of the BIM model of the railways. FFB is BIM ready. Now, ladies and gentlemen, you may ask yourself if it's only possible to install continuous, starting at one point, and go on and end at the end of the track. No, because of the design segmentation, at each necessary place installation can be stopped and continued after the gap. For example, because of a bridge being still under construction or own logistic reason, to cross the track for transportation, a gap with 5 to 10 slabs can be performed, can be kept open, and the installation is running on. As long as the transport opening is no longer needed, the gap can be closed, and the accuracy will be the same after the closing of the gap. Everything will fit. Here we can have a nice view of such a curve section. We see the polygonal arrangement of the slab and the continuous shape of the curve grinded by the CNC machine. And the accuracy of this grinding process is very high. The performance will be executed with a tolerance of less than 0.3 millimeters. So at the end, you will have a continuous support for the rail with the best conditions to ride very fast. On the right side, we have information about the need of rail for installation. The Slab Track system, FFB, will be installed without using a rail. So no concrete will come together during the installation process of the system itself. Only the fastening system will be installed in an assembly process as the last step in the production before storage. The fastening system for high-speed use consists of dowels installed in the concreting process, the elastic intermediate plate, the steel plate, tension clamps, screws, the rail pad on top, and the angle guide plates. Excuse me. This is the assembly process in the plant. The installation of grease as a protection against corrosion. And now the slab is ready assembled and waiting on the storage area for the call of the site. The call can, for example, be in 3 days we need slab number L for left track, 2708, and the following numbers. But this call needs some work before. The systematic installation process, according to the requirements, is the subgrade with a compaction, the frost protection layer with a defined permeability to let the water pass, on top the hydraulic bonded layer, and then in the installation process a wooden spacer. Wooden spacer to lay down the slab, including the fastening system on top. Now after adjustment, the wooden spacer will be eliminated and the area between the bottom of the slab and top of the hydraulic bonded layer, here in the brown color, will be filled with a high fluid cementitious mortar. And now, as a last step, the rail will be installed. To have a look on the side, you can see the slip form paver installing the hydraulic bonded layer on top of the frost protection. And then, after the survey process, the position of each slab will be marked on the HBL, and the gantry crane will lay down each slab at its special place, according to the position plan and the ID number of the slab. A survey team will work with the slab positioning system and a total station and the software behind, adjusting each slab according to the necessary accuracy. And here we are again in the range of 0.3 millimeters using the data we have stored after the grinding process. So we will have no additional failure in the process. We will start with the track alignment, go into the grinding process, we'll use the accuracy after grinding and jump into the installation process, always using the same data. To fill the gap between the hydraulic bonded layer and the bottom of the slab itself must be fixed and the gap must be sealed, what we do with a cementitious mortar. Then the self-compacting mortar will be filled in, and as a last step, the threaded bars installed in the slabs will be coupled with a turnbuckle and special coupling devices. Some reinforcement will be put it into this gap area to protect against cracking. And in the last step, this gap will be filled via concrete. Now we have a more or less endless concrete band with high durability, waiting for the installation of the long rail on top, and as a last step, by welding, the continuous welded rail will be performed. The precast FFB system is also suitable for switch areas. From the design of this switch supplier, all the data for the fixation points will be taken and the geometry will be transferred to transportable sized slabs. Here we use not only the grinding machine but also the CNC technology for drilling the fixation points into this prepared slab, and at the end we will have the slab positioning plan for the adjustment on site. Here we can see such a slab. We will have a flat area, grinded, and the drilled fixation points. Later on, the fastening system will be installed on top. For drainage, we will have special areas with inclination. So it's not necessary to prepare the switch components with sleepers. The elements are very small. You can see here. The transport is quite easy and very economic. And after installation on site, because of the high accuracy of the CNC drilling, no adjustment, no additional adjustment of the steel elements after installation is needed. We have heard quite a lot this morning about the need of noise and vibration mitigation, a very important subject. What is necessary to prepare such a system? A pretty good calculation and also a pretty good measurement of the real situation. So latest in, for example, a tunnel, in the construction of the tunnel, some measurement have to be performed to define the transfer rate from the tunnel to the buildings on top. According to this calculation, for example, a mass spring system with a frequency of 11 or 12 Hertz can be designed. Here we have an example of such a system performed in the Katzenberg tunnel in Germany. We have a tubing element the tunnel is constructed of. We have the filling concrete we have the sidewalks, and then we have the track work area. At the bottom, an elastic material, on top the mass. The FFB slab here works together with a reinforced concrete layer as a mass, and together with the elastic material, this system works as a floating system. Another solution can be to use thicker slabs. Here this slab was performed with a thickness of about 50 centimeters. Given the mass for the mass spring system, and the elastic material here is glued on the bottom of the slab, and below there's underpouring concrete. So quite a lot of solutions are possible, but the acoustical engineers, they have to perform a pretty good work before and give all the information to the supplier of the elastic material and to the designers of the mass itself. Now I want to jump to the world. Some projects performed with the FFB system around the globe. In Europe, about 200 kilometers. Most of the installation have been performed in Asia, in China, with more than 10,000 kilometers. That means more than 1.6 million slab already have been performed there. It's quite a lot experience, and because of this long installation sections, the FFB system meanwhile is the most used system in the world. Also, about 340 switches with, again, the amount of 8,500 slabs for switches have been performed, with best results after installation and the use by the train. At this place here, I want to hand over my mic to Steve again, who will tell you something about the Slab Track solutions for UK high-speed rail.
Thank you, Werner. I'm glad you handed over the mic and not over to Mike. We might have been in some trouble there.
The mic to Steve.
Thank you. Okay, so what have you done to this?
Doesn't work any longer.
Doesn't work.
I killed it.
Is it time to go home?
You've got 5 minutes.
Yep.
Yes?
Done that. No, but I know somebody who can.
Now it works.
Okay, thank you, thank you.
Thanks a lot.
Okay, thank you. Okay, so the partnership of Max Bogl and Tarmac is a couple of years old as far as Max Bogl and Tarmac are concerned. We launched as a joint venture earlier this year, and we very quickly just wanted to give you some of the benefits of the partnership, or explain some of the benefits of the partnership, because of course, as I alluded to earlier, the solution in the for UK high-speed rail will be a full turnkey solution. So therefore, we needed not just to have the technical expertise of Max Bogl, but we also need to think about some UK support, which generally is the model that Max Bogl apply to their overseas, or as far as German overseas is concerned. So the partnership allows the proven technology of FFB system to be produced in the UK, and should we be fortunate enough to be manufacturing and supplying to the UK high-speed rail market, that's what we're going to do. So we're going to be using local labour for manufacturing, transport, which is a very important one, planning and installation, and even maintenance. So we'll ensure we can manage the environmental impacts. We'll obviously look from all of our sustainable material sources. We'll manage all carbon footprints of the installation. We'll utilise BSI-approved management processes and systems. and we're going to look to reduce product supply and manufacturing costs as a result of doing it on British soil. So the benefits also very important are the off-site manufacturing. I know Niall alluded to it earlier. The more we can keep off the rail from every part of the process in terms of the construction and the installation process, it's very important and a key driver for many of our clients in the rail sector now to manufacture off-site. Obviously, the Max Bogl system allows us to do that, so we can manage safety controls, so it will be process driven with a zero harm culture within that manufacturing process. Obviously, transport management is a big one. Sorry if I just come back to that. So essentially the solution for the UK is engineering and design, manufacture, transport and logistics, and installation and supervision, so that's very important to know. Moving on. So it's going to be an integrated solution, as I say. So we've got the support of our assets in the UK, also our ready mix, both technical and production expertise. Transport and logistics is very important to us as a business, which I'll just touch on very briefly. We have a large fleet of vehicles, over 1,700 vehicles in our fleet, 25 trains and sets. We are one of the largest movers of materials in the UK on our British network. And I just wanted to give you a very quick example. If we assume in the UK 100 kilometres of track, that's 15,500 slabs, which would need probably on one line of manufacture with 30 moulds over 2 years to manufacture. That'll be 5,100 vehicle movements, or indeed 120 train movements, which essentially is one train per day. So that's obviously where Tarmac will bring its support expertise. And finally, manufacturing in Tallington. Tallington is, of course, well versed in the supply of rail sleepers to Network Rail. Has done that for many years, and obviously from our Mount Sorrel quarry as well, we've provided many a ton of rail ballast as well. So obviously bringing that full solution together in the UK allows us to, as it said before, do the full turnkey for the UK high-speed rail sector. So thank you very much.